Welcome back, Physics Gain. This is Unit 1B, Part 3 in the Vector and Scalar Quantities section. So this pertains to pages 25 to 28 of your duotang, and the objectives of this is to add two or more non-collinear. So last assignment we dealt with collinear vectors, vectors that lie on the same line. These ones do not. So adding two or more non-collinear vectors to determine the resultant, and solving problems involving non-collinear vectors, so vectors that do not lie on a line. So of course, the first question here, what are they? Kind of explained that already. Vectors that do not lie on the same line. So they're a little more tricky. We just simply can't do it in your head mathematically. So the steps to do this are on page 25 of the duotang. So if you turn to that, you will see all the steps. Kind of summarizing what it says there. So the first one, you draw a vector to scale. So you start off with your first one, draw it how you're supposed to draw it. And of course, you should set the scale. I kind of put this in as an afterthought. What scale are you going to use? What's going to be reasonable on your paper? So you don't want the vectors to be too big or too small. So then draw the second vector to scale by placing the tail at the head of the first vector. So it's like a map direction where you continue on from where you last left off. Then you continue until all vectors are drawn. Then draw the resultant vector from the starting point to the finish point. What I like to do is mark my starting point as an S and the finishing point as an F. Then just join those two. And then measure the resultant vector, and by measure I mean the length, which is the magnitude, and then using your scale to convert it back to the quantity that you're looking for, and also the direction using a protractor. Okay, so on this sheet here I have three examples. I'm going to run the first one with you, and then after that you can pause the video and try the remaining two. Try to do these legitimately, just don't look at the answers, actually try it, because on your quiz you'll have to do that, and of course you won't have anything to back up on. Okay, and again, the resultant is the vector drawn from the starting point to the finishing point. Okay, so the first example here, so there's quite a few examples in the duotang, pages 27 to 28. So this is referred to as the graphical method, where we're actually making a scale and drawing them out. And be sure to follow the steps involved, etc., etc. So the first one, we have two vectors here, 25 meters north 13 east and 50 meters south. So obviously we're not going to draw something that's 25 centimeters and 50 because that's too big. But a nice scale to use is 1 centimeter equals 5 meters. Both these numbers are divisible by 5, so that would work quite well. So if 1 centimeter equals 5 meters in the real world, then we would draw this one 5 centimeters. 5 times 5 is 25, right? And this one, of course, would be 10. If 1 is equal to 5 times 10 times 10, 10 centimeters represents 50. Okay, so that's the first thing. Get the scale nailed down. And again, with direction here, remember when direction is stated in this format, the first direction is where you're starting from, and then the second part, 13 degrees east, is where you're moving to. So starting with north, go 13 east. So if you're looking at your protractor here, you would orientate it like this likely. So straight north is 0, then 13 in the east direction, so right here. Okay. Now I have the whole thing drawn out here. Try to look at it step by step. Kind of ran out of room here, so I had to move into the next question. But if you look here, you start off with the coordinate system. It helps if you have a piece of loose leaf in behind your paper, so you can see the north, south, east, west movement. So if you notice here, my first vector from straight north, I've moved, as you can see, 13 degrees east. So it's pointing there, and as best you can, it's measured to be 5 centimeters, of course, because that is what the scale tells me to do. So you draw your first vector, okay? Then the next vector to that, you're adding this one, and it's 50 meters straight south. So from where I left off, I go straight south. And to represent 50 meters, of course, I'm going to be moving 10 centimeters. So there we go. Notice I have arrowheads here. After the first vector, arrowhead neatly drawn. Second vector, arrowhead neatly drawn. So here's my start. After I've drawn my second vector, that's my finish down here. So the resultant is from start to finish. So you can see it's pointing down here in quadrant 1, 2, 3, 4. Quadrant 4 for those of you who are pre-calc people. And then measuring this out, I measured mine to be around 5.2 centimeters. And of course, to change that back, 1 centimeter equals 5, therefore 5.2 equals, well, 5.2 times 5, because it's 5 times greater. So 26.0 meters. And you'll notice here I have two answers. It doesn't matter which one you have. It all depends upon which direction you started in. So for example, if I start to show that this arrow is pointing down here, I could start south and then measure this angle here using the inner scale of my protractor that I have here. So it looks like it's from south, it's a movement of around 14 degrees in the east direction. Okay? Or I could have chosen to do it from east, and from that I go straight east, and you can see it's around 76 degrees south. So starting straight east, 76 degrees south. Okay, so right now you should pause the video. I think what I'll do is I'll stop the video here and put the final answers as part 2. See you shortly.